Assalamu alaikum dear students. Today our lecture 5 is computation of areas, and this lecture covers the following topics: introduction, different methods of computing area, graphical methods, mid-ordinate method, average ordinate method, trapezoidal rule, Simpsons rule, and instrument method. Let us begin with introduction. The term area in the context of surveying refers to the area of tract of land projected upon the horizontal plane and not the actual area of the land surface. The units of measurement of areas are as follows: square meters, hectares, square feet, acres, and square kilometers. The two methods generally adopted to find the areas of land are as graphical method and instrumental method. In graphical method, the required data is obtained from the measurement of plan. The area may be found with the help of some geometrical figures and by the application of various formulae. On the other hand, the area obtained by the use of instrument, usually a planimeter. The instrument method is less accurate, but it is more commonly used method because it has the advantage of allowing the areas to be obtained from the outline of any shape. Now, graphical method. The area is calculated by computations of the lines as drawn on the plan. The outline of the plot is subdivided into elementary geometric figures, mainly triangles, and sometimes into square and trapezoids. The height and the base of each figure are then scaled to calculate the area, and by adding the sum of all the figures, the total area is obtained. The area may be found by the help of some geometrical figures such as triangles, squares, and trapezoids, and by application of various formulas such as mid-ordinate rule, Simpsons rule, trapezoidal rule, etc. Now, area by geometrical figures. The area may be found out by any of the following methods: by division into triangles and by division into squares. Now, by division into triangles, this is the most common method. In this method, the whole figure is divided into the number of triangles. The base and the altitude of the triangle are scaled, and its area is found out by multiplying half the base and altitude. When the boundaries are irregular, they are replaced by straight lines known as equalizing or give or take lines. These lines are drawn that they exclude as much area as they include, as in figure. The figure is thus replaced by a polygon, which is then divided into triangles. As shown in figure, the whole area can be divided into individual triangles A1, A2, A3, A4 and A5, and the total area of the field can be calculated by the summation of A1 plus A2 plus A3 and A4. By division into squares, it consists in placing over the figure piece of tracing paper ruled out in squares. Each square represents a definite amount of area. The number of complete squares within the boundary is counted, and in addition to the incomplete squares, which are more than half, are counted as complete, and those less than half are neglected. The required area is equal to the total number of squares multiplied by the amount of area which each square represents. Also, various formulas such as trapezoidal rule, Simpsons rule, mid-ordinate rule may be applied for finding the areas enclosed between the adjacent survey lines and curved boundaries. The area between the traverse lines and the actual boundary is determined by taking offsets from the traverse line. The offsets are taken at the regular interval if the boundary does not change the direction suddenly. Otherwise, at irregular intervals, the area between the traverse line and the irregular boundary line is determined by the following methods, and the first method is mid-ordinate method. In this method, the track is divided into segments, and the length of the mid-ordinate of each segment is measured. As shown in figure, the offsets O1, O2, O3, O4, O5 and O6, and the mid-ordinates are calculated H1, H2, H3, H4 and H5. And let D be the regular interval between O1, O2, O2, O3, O3 and O4 and O4, O5. The total area can be calculated by the formula D in bracket into H1 plus H2 plus up to Hn, where H1 is the mid-ordinate between O1 and O2, H2 is the mid-ordinate between O2 and O3, and so on. Now the average ordinate rule. In this method, the length of average ordinate is determined and is used to determine the area of entire track. Let O1, O2, O3, O4, O6 and so on be the offsets along the chain line of length L, total length L. The total area can be calculated by O1 plus O2 plus O3 and so on divided by n into the total length. Now the trapezoidal rule. While applying the trapezoidal rule, boundaries between the ends of ordinates are assumed to be straight. Thus the areas enclosed between the baseline and the irregular boundary line are considered as trapezoids. Now, as shown in figure, let O1, O2, O3, O4 up to n be the ordinates at equal intervals or offsets along the chain line, and let D be the intercept between O1, O2, O2, O3, O3, O4, O5, O6 and so on. Now according to trapezoidal rule, the first area, that is the area A1, is equal to O1 plus O2 divided by 2 into D, that is the average of O1 plus O2 and the common difference. Similarly, second area is equal to O2 plus O3 divided by 2 into D, and third area is equal to O3 plus O4 divided by 2 into D, and so on. The total area can be calculated as A1 plus A2 plus A3 up to AN. The total area comes out to be O1 plus 2 times O2 plus 2 times O3 plus 2 times O4 plus 2 times On minus 1 plus On. And this can be simplified as the total area is equal to first ordinate plus last ordinate divided by 2 plus the sum of other ordinates into length divided by into length. Now Simpsons rule. In this rule, the boundaries between the ends of ordinates are assumed to form an arc of parabola. Hence Simpsons rule is sometimes called the parabolic rule. Now similarly, let O1, O2 and O3 be the consecutive ordinates along the chain line AB, and let D be the common difference between the ordinates O1 and O2. And the area of figure ACD31FA is equal to the area of trapezium ACDF and the area of segment FD31. We know the area of trapezium is equal to O1 plus O3 divided by 2 into 2 times, or AF into CD divided by 2 into 2D, and the area of segment is equal to 2 by 3 into area parallelogram F1 3D. So which on simplification becomes 2 by 3 into O2 minus O1 plus O3 divided by 2 into 2D, and the total area of the figure comes out to be D by 3 into O1 plus 4 times O2 plus O3. Similarly, the area between the next two divisions can be calculated, and the total area by the Simpsons formula comes out to be D by 3 into O1 plus 4 times O2 plus 2 times O3 plus 4 times O4 plus 2 times O5 and so on, which on simplification becomes D by 3 into O1 plus On plus 4 times O2 plus O4 plus O6 and so on, plus 2 times O3 plus O5 plus O7 and so on. And this can be stated as common difference divided by 3 into first ordinate plus last ordinate plus 4 times the sum of even ordinates plus 2 times the sum of remaining odd ordinates. Now the comparison between trapezoidal rule and Simpsons rule. In trapezoidal rule, the boundary between the ordinates is considered to be straight. On the other hand, in Simpsons rule, the boundary between the ordinates is considered to be an arc of parabola. There is no limitation. It can be applied for any number of coordinates. This rule, while on the other hand, Simpsons rule, this rule can be applied when the number of coordinates must be odd. Trapezoidal rule gives approximate results. On the other hand, Simpsons rule gives more accurate results than trapezoidal rule. Now, instrumental method. The instrument used for computation of area from the plotted map is called planimeter. There are various types of planimeter in use, but the Amsler polar planimeter is most commonly used now. It was invented by Professor J. Amsler-Loffen in 1854. That is why it's known as the Amsler planimeter. It consists of two arms. The arm A is known as the tracking arm. Its length can be adjusted and it is graduated. The tracing arm carries a tracing point which is moved along the boundary line of the area. There is an adjustable support which always keeps the tracing point just clear to the surface. The other arm is known as the pole arm or anchor arm and carries the needle point weight or fulcrum at the end. The weight from the center of rotation. The other end of the pole arm can be pivoted at the point by a ball and socket arrangement. There is a carriage which can be set at the various points on the tracing arm with respect to vernier of the index mark. The carriage consists of measuring wheel and a vernier. The wheel is divided into 100 divisions and vernier into 100 divisions. The wheel and the vernier measure the readings up to 3 places of decimal. The wheel is geared to counting the disc which is graduated into 10 divisions. For the 10 complete revolutions of the wheel, the disc shows a reading of 1 division. Thus, planimeter shows the reading of 4 digits. The planimeter rests on the tracking point, anchor point, and the periphery of the wheel. The area calculated with this method using instrument planimeter is given by A is equal to M into FR minus IR plus minus 10N plus C, where A is the area of plan or figure, M is multiplier of a planimeter whose value is marked on the tracing arm next to the scale division. FR is the final reading, IR is the initial reading, N is equal to number of times 0 of the dial has passed the fixed index point. C is equal to constant of the planimeter whose value is marked on the top of tracing arm just above the scale of division. Please note that the constant of the instrument is to be taken into account only when the point is situated inside the figure. If the 0 mark of the dial passes into the clockwise direction, use plus sign, and if it passes in anti-clockwise direction, use negative sign. The accuracy of setting tracing arm for any particular unit may be verified by drawing a trial square or rectangular of a known size and measuring its area. The surface of the paper on which the wheel rolls must be smooth but not so highly glazed. It's unlikely to get satisfactory results from the drawings which have been folded. Now, I have uploaded the numericals and the notes of this lecture. Please read the notes carefully and try to solve the numericals and tally your answers and the solutions with the given solutions. With this, I conclude this lecture. Thank you.